Hi there. So we've been representing data for a while now. We're looking at scatter graphs, which is something you've probably come across before. Not particularly difficult. They're talking about something slightly different in terms of correlation. Now, correlation is where you have two aspects where as one gets bigger, the other one gets bigger. This might mean that one causes the other to get bigger, but not necessarily. So don't confuse correlation with causation. Let's just have a little look at this. It's not too tricky, to be honest. It's one of those bits that sometimes people doing A-level maths say, this isn't real maths. But it is real maths because it's logical thought and thinking logically and then making real calls on that helps us to solve problems, which is what maths is all about. And if we don't link it into real life every now and then, people start to say, what's the point of maths? And that would be a terrible thing. Before we look at any examples, I just wanted to say one or two things about correlation, because you'll be asked to describe correlation, and the three basic things you're going to want to say are either positive, and that means that the line of best fit would be going up from left to right. Where's the line of best fit here? There it is. Then all of the crosses are very close to that line. But if I were to just take out one or two, like that one that's right close to it and that one that's right close to it, and I were to move them a little bit further out, then all of a sudden we're starting to look at a slightly weaker line of best fit. So if we put a few more in that were more loosely scattered, there is still a very definite tendency to go up from left to right, but it's harder to predict with any accuracy if you know the value of one thing, what the other one would be, because it could be anywhere within a fairly wide boundary. So we have strong or weak correlation, and we have positive correlation or negative correlation, which looks like that. And so so that's down from left to right, because as one thing gets bigger, the other gets smaller. And it's like being in the middle of a capital N. You couldn't do that with that line. And finally, you'd have no correlation at all, which is simply a scattering of points all over the place. And that's about it for starting off. Now, whenever you're asked to come up with a reason for anything, just go with whatever makes most sense in your mind at the time. Use what we often hear being talked about as common sense, but if you're anything like me, you start to doubt whether or not that really exists. It's common sense. What does that mean? It means a sense that's common to all. That's a rare thing to find. Okay, so here's a question in three parts. First, we've got to draw a scatter diagram. Then we need to describe the correlation, and then we need to interpret it. So have a go at all of those. Pause the video and then we'll carry on. So here's my axes. You can make them whatever you like as long as they're consistent ones. And then we just need to start plotting points. So 0.6 kilometers will be 0.6 along there, and then 50 up there. B 3.8 kilometers, 3.8, so if I measure along there, that would be to there, and 3.8, 22. And then if I carry on plotting those, I should get something like this. And it doesn't ask you to draw a line of best fit, but why not? I mean, that's the most fun part of so I always reckon put a line of best fit in there somewhere. Now, next year, we get on to calculating exactly where that should go. But for now, that'll do. It's just making the point that we're going down from left to right as well, which helps me answer part B to describe the correlation. The correlation is negative. Now, is it strong or weak? I'd say it's quite weak because most of those crosses are a bit of a distance away. So I'm going to call that a weak negative correlation. Saying it's weak doesn't mean it's not there. It's definitely there. And then it says interpret your answer to part B. Well, to do that, I should do what I've been ignoring at the beginning, and that's bad. Actually, I should have read that at the beginning. So this is about a city whose population density in people per hectare. A hectare is an area of land that's 100 metres by 100 metres. And the distance from the city in city centre in kilometres was investigated by picking a number of sample areas with the following results. So the population density gets less and less the further away you are from the centre of the city, which is what's going on. Oh, I've just done it. I've interpreted it. Population density gets less the further you travel from the city centre. Or you could describe it in the other way. As you get closer to the city centre, you get more and more people. Here's the next question. Pause the video and give it a go. Right, so the type of correlation shown. It's, if you ignore that one, it's going down slightly, isn't it? So I would say that that was weak negative. Hideki says that her data supports the conclusion that more education causes people to earn a lower hourly rate of pay, which is sort of what you might think that's showing, isn't it? That does go with it. Give one reason why Hideku's conclusion might not be valid. Well, there's a couple of things to say here. One is she's asked all of her friends, hasn't she? And her friends might not be very old, in which case they might not have left for that long. So those who left school when they were 16 would have been in the job market for longer, and maybe worked at one place and that they've got promoted and all that sort of thing. Whereas those that have stayed that have stayed in education for longer may not have actually got a job yet. They may still be in education, so that might be why they're not earning so much money, because they might be taking on bar jobs or whatever to keep themselves going through it. So anything like that is the sort of thing you want to be going for. Here's another question. So pause the video again, have a little go. Now these crosses are all over the place, so we've got to say there's no correlation. And then we've got a claim here that hotter cities have less rainfall. Well, that may be true, but if there's no correlation, you've got nothing to back that up. So although you might want to show though that you've noticed that although the hottest city has no rainfall, other hot cities have a lot. So all you have to do is say this claim is false, as there is no correlation. Right, we're going to do one big question and then that'll be it for this. We've got a multi-part question here. I'm going to show it to you one bit at a time. So do one bit and then pause and carry on as we have been. So I've started off by finding the interquartile range. That one, take that one. Then I times it by 1.5, which is what they've told us to do, and you get 7.125. We're at the upper end for this one, aren't we? This is above it. So if we add this to the upper quartile, you get 11.975. So because 21.7 is bigger than 11.975, it must be an outlier. So we've shown it. Here's part B. So we need a reason you might include the outlier and one why you might disclude it. Well, to include it, you have no reason to believe that it's false, do you? But to exclude it, You might exclude it because it's not typical of what's going on, and therefore it might not be useful in predicting what we need to do. So I might write something like this. There's no reason to believe it's false, but then, as it's an outlier, it's not representative of typical rainfall that month. Right, here's the next part. You need to draw a scatter diagram. So take your time. There's 3 marks for it, so it's worth taking your time over, and it's quite easy really. If you're struggling to set up your axes, a little bit of advice I'd give you is always go for 5 or 10 squares for every 10. It makes it much easier to split up any whole numbers, and generally put time along the bottom, but it doesn't actually matter if you don't. And hopefully you should have something that looks a bit like this, and you can see there's the outlier up there. Loads of rain compared to any of the other days. You also think you might want to keep it in because that's going to be a significant amount of the whole month's rainfall, so it is important. Anyway, 2 more questions to go. First of all, describe the correlation between rainfall and hours of sunshine. And that's just, is it positive, is it negative, is it nothing at all? Well, there is a bit there, isn't it? It's definitely, there's only one in this part that's nothing, most of them that are nothing there. So I would call this a weak negative correlation. And then there's just going to be one bit of interpreting to do next. So, do you think there is a causal relationship between the amount of rain and the hours of sunshine on a particular day? Explain your reasoning. Now, this is causal, so we want some kind of reason about what's actually going on. So you need to be saying something about why there isn't as much sunshine when it rains. And, well, when it's raining, there's clouds around, aren't there? So I've gone with this. There could be a causal relationship, as you need clouds to make rain. So days with rainfall will be cloudy and therefore less sunny. Okay, that's alright for this week. See you next time, folks.